All right, today we are working on derivatives of inverse trig function. In previous class, we worked on the derivative of trigonometric function, but today we are working on the derivative of inverse trig function. One very important thing that you need to note here is this. For example, if I want to write the inverse of sine, we write like this. We read this as sine inverse x, or sometimes we also write the sine inverse or inverse trig function like arc sine. If you see arc sine, meaning of that is inverse sine. They are exactly the same thing. So if I want to write inverse of cosine, we write cosine inverse x or arc cosine x. They are the same thing. So to denote the inverse trig function, we use this one, the little symbol like power -1. It's not power -1, but it's that notation for the inverse. So we can write the inverse like this, or we can write arc sine, arc cosine, arc tangent, and so on. So that is very important notation that you need to know. Please don't confuse with these two things. When you see inverse or arc, they are the same thing. And here we have the list of formulas that we need to remember in order to compute the derivative of the inverse trigonometric functions. The first one, the derivative with respect to x of sine inverse x is 1 over the square root of 1 minus x squared. And if it is cosine inverse x, then it will be negative 1 over the square root of 1 minus x squared. And remember that x is always between -1 and +1, because the inverse sign is defined in this domain, that is the domain of the function. Similarly, derivative of tangent inverse is 1 over 1 plus x squared. So the derivative of inverse cotangent or cotangent inverse, or maybe arc cotangent, is negative of 1 over 1 plus x squared. And this is defined for tangent inverse and cotangent inverse. It is defined for all values of x. So the domain is from -infinity up to +infinity. Similarly, the third set of formula, the derivative of secant inverse x is 1 over the absolute value of x times the square root of x squared minus 1. And for cosecant, it is the negative of that. And the domain for this one, secant inverse and cosecant inverse, is the absolute value is greater than 1. Meaning of that is the x must be more than 1 or x must be less than -1. So meaning of this one is x is greater than +1 or x is less than -1. In both cases, the absolute value will be more than 1. So these are the 6 formula that we need to remember before we begin the computation of the derivative involving inverse trigonometric functions. Example, find the derivative of the following functions. Let's work on part A. In part A, we have f of x is equal to the square root of 1 minus x squared plus x times the sine inverse x. So you can see here the first function is a square root function. We already know the derivative of a square root function. If you remember, the derivative with respect to x of square root of x is 1 over 2 square root of x. And the second formula that you need to remember here is, here I can see sine inverse. The derivative with respect to x of sine inverse x is equal to 1 over the square root of 1 minus x squared. We'll be using these two formulas here along with some other rules. So let's get started. Here our function is f of x. So the derivative can be written as f prime x, just like dy over dx. This is the other notation. We can write f prime x equal to, now first we need to find the derivative of this one. This function is a square root function. Derivative of a square root function is 1 over 2 times the square root of whatever is there under the root. So that will be 1 over 2 times the square root of 1 minus x squared. But this function has the outside function, the square root. I got that. Also, it has the inside function. If it has the outside function and inside function, we have to use the chain rule. That is, after we find the derivative of outside function, that is the square root function, we have to multiply by the derivative of inside function. So multiply that with the derivative of inside function, which is 1 minus x squared. So that is the derivative of this first one. Then we have a plus, and then we have to find the derivative of this product, x times the sine inverse x, the product. So we have to use the product rule there. The product rule says the first function x multiplied to the derivative of the second function, which is sine inverse x, plus the second function, which is sine inverse x, multiplied to the derivative of the first function, which is x. Derivative of the first, that is x. So here we use the formula and the rule to differentiate in this step. In the first step, we use formulas, these two formulas, the chain rule in the first and the product rule in the second, to go from first step to the second step. So this is equal to, the first one is 1 over 2 times the square root of 1 minus x squared. And we are multiplying this by the derivative of this one. Derivative of 1 is 0. And then we have a minus. And derivative of x squared, if you use the power rule, 2 will come down and reduce the power by 1. So that becomes negative 2x. So we are multiplying that by negative 2x. That is the first one. Plus, now here we have x. That is my x multiplied to the derivative of sine inverse x. Here is the formula. Derivative of sine inverse x is this one, which is 1 over the square root of 1 minus x squared. Then plus we have sine inverse x multiplied to derivative of x with respect to x is 1. Few more steps. Now here you can see in the numerator there is 2, in the denominator there is 2. So those 2 will get cancelled. 2 over 2 is 1. Then what is remaining is negative 1 multiplied to negative x. That is negative x over, in the denominator, square root of 1 minus x squared. And then plus, the next one is 1 times x. X over the square root of 1 minus x squared. Then plus 1 times sine inverse x, that is sine inverse x, which is equal to, now if you look at this line carefully, what you'll see is the first quantity and second quantity are same. The first one is negative and second is positive. That means they cancel each other. So the remaining quantity from this line is sine inverse x. So that is the derivative of the function given here in part A. Now let's work on part B. In part B, we have, let me write here, we have f of x is equal to arc tangent, meaning of that is tangent inverse the square root of 1 minus x over 1 plus x. Now, in order to find the derivative of this one, because this is the inverse tangent, we need to know the formula for the inverse tangent. Derivative with respect to x of inverse tangent is equal to 1 over 1 plus x squared. That's the formula to find the derivative of inverse tangent function. Now, if you look at this function here, we have f of x equal to inverse tangent, but in place of x, we have this big quantity, which is square root of 1 minus x over 1 plus x. So we have to use the chain rule here. That is, we have to find the derivative of outside function and then multiply by the derivative of this inside function. So what I'm saying is this. This implies the derivative is equal to derivative of outside function, the derivative of tangent inverse is 1 over 1 plus x squared. 1 over 1 plus In place of x, I have this one. So when you square that, it will be 1 minus x over 1 plus x. So that is 1 over 1 plus x squared. Then we have to multiply by the derivative of the inside function. And the inside function is square root of 1 minus x over 1 plus x. So in first step, we use the chain rule. We have the derivative of outside function, that is tangent inverse, which is 1 over 1 plus x squared. 1 plus x squared is the square of this quantity. When you square it, the square root will go away. And then you multiply by the derivative of inside function. Here the inside function is square root of 1 minus x over 1 plus x. That is the first step. So this implies f prime x, the derivative is equal to. Now, if I want to simplify this complex fraction, if I want to simplify something like this, here is 1 plus x in the denominator. So in order to simplify something like that, what I can do is I can multiply both numerator and denominator by this denominator, which is 1 plus x. So I'm going to multiply the denominator by 1 plus x and also the numerator by 1 plus x. Why? In order to remove this crazy denominator which is there and to simplify this complex fraction. So what happened by doing that? 1 times 1 plus x, that is 1 plus x. And in the denominator, 1 plus x multiplied to 1. 1 plus x multiplied to this one is 1 plus x. And 1 plus x multiplied to this one. See, if I multiply there, this 1 plus x will go here and it will cancel with this 1 plus x in the denominator. Because in the numerator, you'll have 1 plus x. Also in the denominator, there is 1 plus x. So 1 plus x and 1 plus x cancel. You'll be here with or left with 1 minus x. 1 minus x. So we simplify the first one. And after you simplify the first one, still some beautiful thing is going there. Look at the second one carefully. Look at the screen carefully. We are calculating the derivative with respect to x of this square root function. And you know the derivative of the square root function. If you remember, the derivative with respect to x of the square root of x is 1 over 2 square root of x. That is the formula. So I'm going to use that formula first. So it will be 1 over 2 times the square root of, in place of x, I have 1 minus x over 1 plus x. Then that is the outside function. Derivative of this is square root, outside function. But it also has the inside function. So if there is an outside function and inside function, we have to use the chain rule. So we have to multiply by the derivative of inside function. Multiply by the derivative with respect to x of the inside function, which is 1 minus x over 1 plus x. The derivative is equal to, here if we simplify the denominator, in the denominator, this one, x and x cancel because one is negative, the other one is positive. So by canceling that, we get 1 plus x in the numerator, and then 1 plus 1, 2 in the denominator. Then multiply 2. If you look at the second one carefully, I want you to look at the screen. Here we already have 1 over 2. Let me write that. 1 over 2. And inside the square root, I have 1 minus x over 1 plus x, but that is in the denominator. If a quantity is in the denominator, that is the reciprocal. So I can rewrite that as 1 plus x over 1 minus x. If I want to write this without 1 over, the fraction will flip. So it will be square root of 1 plus x over 1 minus x. Then multiply 2. Okay, I'm done with the first one. I'm done with the second one. Now I have to go to the third one. Now again, I want you to look at the screen very, very carefully. In third, we have the derivative with respect to x of this quotient. So if it is a quotient, we have to use the quotient rule. Now the quotient rule says denominator, which is 1 plus x. I'm going to use the quotient rule directly here. Denominator multiplied with the derivative of numerator. Everybody look at the board. This screen. Derivative of numerator, derivative of 1 is 0. Derivative of negative x is negative 1. Because negative will remain as it is. Derivative of x with respect to x is 1. So negative. So what I did, denominator times the derivative of numerator minus the numerator now. Numerator is 1 minus x times the derivative of denominator times the derivative of denominator. Derivative of 1 plus x is 1. Because derivative of 1 is 0 and derivative of x is 1. So 0 plus 1 is 1. And we divide everything by the square of the denominator. Denominator is 1 plus x. We square it. So that is the next step when we go from here to here. So this implies the derivative is equal to, I have 1 plus x there, divided by 2, then I have 1 over 2, then I have 1 plus x with the square root. Square root means power half. In the denominator, I have 1 minus x with the square root, meaning of that is power half. And then multiply 2. Now, I want all of you to look at this screen carefully again. I'm going to simplify this fraction and write down here. But before that, look at it carefully. If I multiply 1 with this 1, negative 1 with 1, that will be negative 1. Negative 1 with x, that will be negative x. And then when I multiply this one here, 1 times 1 minus x with negative in front. So if I multiply by 1, it will be 1 minus x. And if I distribute this negative, when this negative goes in, that will be minus 1. If this negative goes in, negative and negative will be positive x. So if you look at that carefully, you can see that there is a positive x and negative x that will get cancelled. And we get negative 1 and negative 1, which is negative 2. So negative 2 in the numerator. And in the denominator, I have 1 plus x quantity squared. 1 plus x quantity squared. So that is the next step. So this implies my final answer will be the derivative is equal to. Now, if you look at it very carefully, here is a negative 2, here is a 2. You can cancel that. 2 over 2, we can cancel that. So let me cancel that. These 2 and this one. I'm canceling that. And after I cancel, now let me start simplifying things together. This negative, which is a negative 1, multiplied to 1, that's a negative 1 over 2. So what I got is negative 1 divided by 2, negative 1 divided by 2. That is the number. I simplified the numbers. Now, we need to simplify these quantities. Here is 1 plus x. Here is also 1 plus x. Here is also 1 plus x. So if you look at this carefully, the first one is 1 plus x with power 1. And then here we have 1 plus x with power half. That means we have a total of 1 plus x with power 1.5 in the numerator and 2 in the denominator. So meaning of that is you have 1.5. If you take that to the denominator, 2 minus 1.5 is half. Meaning of that is the square root of 1 plus x. Half in the denominator, that is 1 plus x. And then we are done with 1 plus x. This is gone, this is gone, this is gone. And here we have, already we have in the denominator square root of 1 minus x. Square root of 1 minus x. So the final result will be negative 1 over 2 times the square root of 1 plus x multiplied to 1 minus x, which is 1 minus x squared. Because a plus b multiplied to a minus b, we know the formula. It is a squared minus b squared. So 1 squared is 1 and the b squared is x squared. So this is the derivative of the function which is given here. Inverse tangent is square root of 1 minus x over 1 plus x. We use a lot of formulas, a lot of rules, so many times chain rule, and a lot of algebraic simplification to get to this one. Example, find the derivative of the following functions. Here we have the functions, that is the combination of the trigonometric functions. So in part A, we have to find the derivative of y equal to cosine of sine inverse x. So we need to know the derivative of cosine, and also we need to know the derivative of sine inverse for this one. So the formula that we'll be using in this one is the derivative with respect to x of cosine x from last class. If you remember, it is negative sine x, and the derivative of sine inverse, derivative with respect to x of sine inverse x from today's class is equal to 1 over the square root of 1 minus x squared. So we'll be using these two formulas to solve the first part, part A. So dy over dx, that is the derivative, is equal to, this is the composite function. Our outside function is cosine and the inside function is sine. So we have to use the chain rule, that is the derivative of outside function. Derivative of cosine is negative sine. So we write negative sine of whatever is there inside. So inside that we have sine inverse x. Multiply with the derivative of the inside function, derivative of sine inverse x or arc sine. This is equal to negative, if you remember from your trigonometry, sine of sine inverse, that is the composition of function and the inverse. So that means these two will undo each other. Okay, sine and sine inverse, they will undo each other and you will be left with x only. That's what you know from your trigonometry. Sine of sine inverse x is equal to x, and that negative is still there. Multiply to the derivative of sine inverse x. We know the formula. Derivative of sine inverse x is 1 over the square root of 1 minus x squared. So there is nothing much to simplify there. So derivative of y with respect to x equal to negative x multiplied to 1 is negative x divided by the square root of 1 minus x squared. So this is the derivative of the function y equal to cosine of sine inverse x. Now let's work on part B. In part B, we have y equal to tangent of 2 tangent inverse x. So when you look at it carefully, we are looking at the derivative of tangent and also the tangent inverse. If you remember from last class, the derivative of tangent x is secant squared x, and the derivative with respect to x of tangent inverse x from today's class is 1 over 1 plus x squared. So we are going to use these two formulas in order to find the derivative of this function. So we write like this, dy over dx, the derivative is equal to, if you look at this function carefully, you can see that this is the composite function. Outside function is tangent and inside function is 2 tangent inverse x. So we are going to use the chain rule, which says the derivative of outside function, derivative of outside, that's derivative of tangent, is secant squared, keeping the inside function same, 2 tangent inverse x, multiply with the derivative of inside function, derivative with respect to x of 2 tangent inverse x. So we use the chain rule here. This is our chain rule. This is equal to, we have secant squared 2 tangent inverse x multiply to, here you can see we are finding the derivative with respect to x of 2 times tangent inverse x. So 2 is a constant multiple. So if you remember that rule, constant multiple rule, we'll pull these 2 outside. We'll write like that. Then we multiply by the derivative with respect to x of this function, derivative with respect to x of tangent inverse x. Derivative with respect to x of tangent inverse x is 1 over 1 plus x squared. So it is 1 over 1 plus x squared. Now after this, we don't have much to simplify. In the numerator, we have 2 times 1 times secant squared 2 tangent inverse x. So 2 times 1 is 2 multiplied with that quantity. So 2 secant squared 2 tangent inverse x. And in the denominator, we just have one quantity, which is 1 plus x squared. And this is the derivative of this function y equal to tangent of 2 tangent inverse x. Part C, we have y equal to sine of 2 sine inverse x. Very similar to part B. You have sine function as the outside function and 2 sine inverse x as the inside function. So in order to find the derivative of this function, I need two formulas. The first one is the derivative with respect to x of sine x. You know that the derivative of sine x is cosine x. That is what we know from previous class. And the derivative with respect to x of the inside function. For the inside function, there is sine inverse x. So we'll be using that formula. Derivative of sine inverse x is 1 over the square root of 1 minus x squared. So let's use the rule here and also the formulas. The first one, you can see y equal to sine 2 sine inverse x. So the first one we are using is the chain rule. Chain rule says the derivative of outside function, that is derivative of sine is cosine, keeping the inside function same, multiplied by the derivative with respect to x of the inside function, which is 2 sine inverse x. That is equal to cosine of 2 sine inverse x multiplied to, this is a constant multiple, so you can pull that 2 outside and then multiply by the derivative of inside function, this one, whatever is remaining there, derivative with respect to x of sine inverse x, and derivative of sine inverse x is 1 over the square root of 1 minus x squared. So there is nothing much to simplify. In the numerator, we have 2 times 1, which is 2 multiplied to that quantity. So that will be 2 cosine of 2 sine inverse x. And in the denominator, we just have this quantity, which is the square root of 1 minus x squared. So this is the derivative of the function y equal to sine of 2 sine inverse x.